Okay, here is homework 3, problem 2. And as I said in the first video in this series, the first thing we've got to do is decide whether or not we need to apply Kirchhoff's current law as well as Kirchhoff's voltage law. Mesh analysis usually means Kirchhoff's voltage law is applicable, but if we have a current source in the circuit, then it's probably true we need to apply Kirchhoff's current law. And we have a current source in this circuit. It's IS on the right hand side here. So we need to apply a Kirchhoff's current law equation. And the Kirchhoff's current law equation we need to apply is basically IS, and get that, is basically IS equals I2. Right, so that's why our KCL equation, that's our KCL equation, is a freebie, right? We get the answer straight away. The second one is a little different, so it's going to be, we got I1, and so the I1 mesh is minus VS plus VR1 plus VR2 equals 0. Right, so minus VS is 13 volts, so minus 13 plus VR1, which is R1, which is what, 6,000, I1, and then R2 is 8,000 times I1 minus I2, because I2 is going in the opposite direction, and that equals 0. And then we can just well, we could leave that the way it is. That's all I did here, but we could probably rearrange it, plug the value for I2 in, and then we solve for I1. Okay, let's do that. So the it's going to be 14,000 I1, so 14,000 I1 minus 8,000 I2 equals 13, and we know what I2 is, right? So it's 14,000 I1 equals 13, and it's going to be plus 8,000 times 0.307, so I1 equals 13 plus 8,000 times 0.0007 on 14,000, and that hopefully equals 1.329 milliamps. But let's grab MATLAB, and I'm not going to do a separate thing for it. I'm just going to say I1 equals 13 plus 8,000 times 0.307 divided by 14,000. And I need to go format long and reprint I1. Right, so it's 1.329, which is what I had before. Okay, now I just realized that I didn't answer question 1. Haha. So for those of you who the question was, what is the output voltage, right? So we need to find what V out is. So V out, to get the answer, right, to actually answer the question, is going to be R1 times I1 minus I3, right? And that's going to be 8,000 is R1 is 9,000, and then I1 is 2.411, and I3 is 2.264. Okay, and I put an extra 0 in there, so let's just erase that extra 0 because it should be 9,000. Okay, and that's the way you get the output voltage. So now back here, the question is a bit different, because it's still the same question, what's the output voltage, and the output voltage is here. But now all we know is that it's the voltage across the current source. So now we have to go back and apply Kirchhoff's voltage law for I2. So, oops, let's just make that a little, let's make it a little thinner. And in fact, let's erase that and go back to a pen rather than a marker. So the I2 mesh does, so we're going around here, so that's plus, that's minus, that's plus, that's minus, and we have that is VR2 plus VR3 plus Vout equals 0. Right? VR2 is nothing more than R2, which is 8,000, times I2 minus I1. VR3 is nothing more than 9,000 times I2, and plus Vout equals 0, so Vout equals 8,000, well, minus 8,000, I2 minus I1, minus 9,000 I2. And that will get you the answer for Vout. Okay, so effectively you do have to apply Kirchhoff's voltage law in this case to find the voltage across the current source. But you can only apply that at the end once you know everything else about the circuit. Okay, so I'm going to kill this video and start on a new video for question 3.